Hello everyone, I am Dr. N.Senthil, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session. In this session, topic to be covered is parallel versus distributed computing under Unit 1, distributed and cloud computing. At the end of Unit 1, students will be able to describe both features of parallel and distributed computing in cloud. At the end of this session, the students will be able to understand the principles of parallel and distributed computing. Cloud computing is a new technological trend that supports better utilization of IT infrastructure, services, and applications. It adopts a service delivery model based on a pay-per-use approach, in which the users do not own infrastructure, platform, or applications, but use them for the time they need them. These IT assets are owned and maintained by service providers who make them accessible to the internet. Okay, now we will see about eras of computing. Two fundamental and dominant models of computing are sequential and parallel. The sequential computing era began in the 1940s. The parallel and distributed computing era followed it within a decade. The four key elements of computing developed during these eras are architectures, compilers, applications, and problem-solving environments. The computing era started with a development in hardware architectures, which actually enabled the creation of system software, particularly in the area of compilers and operating systems, which support the management of such systems and development of applications. The development of applications and systems are major element of Windows 2 as and it comes to consolidation when the problem solving environments were designed and introduced to facilitate and empower engineers. This is when the paradigm characterizing the computing achieved maturity and became mainstream. Moreover, every aspect of this era underwent a three-phase process: research and development, commercialization, and commoditization. Now we will discuss about parallel and distributed computing. The term parallel computing and distributed computing are often used interchangeably, even though they mean slightly different things. The term parallel implies a tightly coupled system, whereas distributed systems refers to a wider class of systems, including those that are tightly coupled. Parallel computing more precisely, the term parallel computing refers to a model in which computation is divided among several processors sharing the same memory. The architecture of parallel computing system is often characterized by the homogeneity of components. Each processor is of same type and it has the same capability as others. The shared memory has a single address space, which is accessible to all the processors. Parallel programs are then broken down into several units of execution that can be allocated to different processors and can communicate with each other by means of shared memory. Originally, parallel systems are considered as those architectures that featured multiple processors sharing the same physical memory and that were considered a single computer. Over time, these restrictions have been relaxed, and parallel systems now include all architectures that are based on the concept of shared memory, where this is a physically present or created with support of libraries, specific hardware, and a highly efficient networking infrastructure. For example, a cluster of which of nodes are connected through an infinite band network and configured with distributed shared memory system can be considered as a parallel system. The term distributed computing encompasses any architecture or system that allows the computation to be broken down into units and executed concurrently on different computing elements. Whether these are processors on different nodes, processors on the same computer, or cores within the same processor, distributed computing includes a wider range of systems and applications than parallel computing and is often considered a more general term, even though it is not a rule. The term distributed often implies that locations of the computing elements are not the same, and such elements might be heterogeneous in terms of hardware and software features. The classic examples of the distributed computing systems are computing grids and internet computing systems. In the summary of this session, we learned about parallel versus distributed computing. I hope you found this lecture is more useful. Thank you and have a pleasant day.